When taking mechanics of material course, you will often come across a subject called Poisson's ratio, and in this video we will be going over what that is. So first, let's take a look at the definition of Poisson's ratio. Poisson's ratio is defined as the negative of the ratio of the lateral strain to the axial strain of an unaxial stress. In simpler words, meaning that when an object experiences an applied load on one axis, the other axis will also respond in either decreasing or increasing in length, depending on its material property. Because Poisson's ratio is a ratio of strain, which is a unitless number, Poisson's ratio will also be unitless. Most materials for mechanical applications, as mentioned, behaves under the category of positive Poisson's ratio, meaning that when one axis is in elongation, another axis will be in compression. You can see when L increases, R also decreases on this diagram. Not all materials, however, behave under the category of positive Poisson's ratio. Some materials are categorized as negative Poisson's ratio, meaning that when one axis is in elongation, another axis will also be in elongation. So how do we determine the changes in material with Poisson's ratio? Poisson's ratio is defined as negative lateral strain over positive longitudinal strain, and each part can be further broken down with the strain deflection formula into strain equals deflection over length or deflection over radius, depending on the axis of interest, shown on this slide. Now let's look at some real-life demo of the Poisson's ratio.
I believe in miracles. I see miracles. Because everybody's looking for miracles. And a miracle is happening tonight. I'm gonna take it slow. Back on the street. I'm gonna take my time. Now I'm back on my feet. And all that we ever do, you must fight just to keep them alive. That's my only advice. Tell me, baby, I've been around the world, all over the world, but I ain't seen myself another girl. 'Cause I need to know now. There's just one thing I need from you. Are you telling me to give me a sign? I believe in miracles all over the world. I still believe, 'cause that makes me crazy. I believe in miracles all over the world. We must fight just to keep them alive. Yeah, I see miracles.
Finally, let's look at how we would solve a Poisson's ratio problem on a homework or on an exam. To begin the problem, we first notice the P to be 80 kilonewtons and elastic modulus to be 200 gigapascal. For the first part of the calculations, we need to find the normal stress by knowing that force over area would be 16 megapascal. Then we need to find the strain by knowing that normal stress over elastic modulus would be 80 times 10 to the negative 6, which is unitless. We then need to find the elongation of z direction by doing Young elastic modulus multiplied by L, which is the original length, which will come out to be 120 micrometers. From the Poisson ratio formula, we can then determine the strain in y direction to be negative 25.6, which is also unitless. Finally, then, we can obtain the changes in all dimensions. For changes in x direction, we will get negative 2.56 micrometer. For direction y, we will get negative 1.28 micrometer.